So before I get started in the next part of this video, I just wanted to show you guys some of the tubes that were included with this valve radio that I'm converting into a guitar amp. These are all untested. I don't know if they work. We're going to find out sooner or later, but for now, let's check them out. So here's a Mullard. It says made in Australia, and it's a 5Y3 GT. So here's our rectifier tube. I'm going to put that down. And then here is our 6SL7 GT. Now, this is a Bryma. It is an original Bryma, made in England. The great thing about Bryma, I recently found out that they started manufacturing again. The other two valves that came in this is a Mullard as well. It's a 6AN7, and we can see this beautiful grid around the outside. This is also Mullard and made in Australia. Again, I don't know if it's working. However, the getter looks really nice and shiny, and the bass doesn't look like it's had excessive heat. Here's another Mullard, made in Australia, 6N8. Made in Australia, Mullard. It's got the getter on top. It's also got the getter on the sides as well. And look at those pins on the inside of the glass. Look how hefty they are. None of these little wires and bits and pieces. That's some chunky stuff right there. So fantastic looking tubes. And let's go over to our computer where I'm going to start doing some research and find out more about these valves, as well as finding out what the best options are for turning this into a guitar amp. Howdy everyone, welcome officially to the part 2 of this valve amp remake, if you will, or repurposing, going from a radio or a CB radio we may have discovered into a guitar amplifier. We're starting off here with the rectifier tube. Now it came with a 5Y3 GT, that's what we're going to stick to. However, what is also a good little tube to go with is a GZ34. Let's type that in, data sheet, and have a look and compare the specs. If you can hear that helicopter flying overhead, it's because we have had some bushfires here and there's a lot of choppers flying around. Alright, so see if we look here, now this is an Amperex tube, 5AR4 or a GZ34. Now this tube can exceed the current that the B plus needs. However, if we look here, the heater voltage is 5 volts and it's 1.9 amps. So if we go back to the GT, 5Y3 GT, we can see it uses 100 milliamps less. Now obviously being tubes, you know, this is plus or minus whatever percentage of error. They're never perfect. However, what we might find is that with a GZ34, a 5AR4, we might get a higher plate voltage coming out. The other thing I like about a GZ34 is that it takes longer to warm up, which means it's more gentle on our power tubes. That's something to think about. Now, this is important to make sure that we pick the right rectifier tube because, and this is something that a lot of people may or may not be aware of, when we have our very first filter capacitor, okay, the big DC caps that filter our AC current after the rectifier, and they filter out the ripple. Now this is important because what can happen is we have to look at the condenser type. Now here, see here it says maximum capacity condenser input filter, and it says 60 microfarad. And if we go here to a 5Y3 GT input capacitor, which they're saying input and output, they're using different words, but it means the same thing, 20 microfarads. Okay, can you guys read that there? I hope you can. Now this is important to know because if we decide to go with a 5Y3, the first filter cap that comes off pin 8, the first node, that has to be no larger than a 20 microfarad. Now it can be 22, it can be 15. it can be any size smaller. The 22 is the closest we're probably going to find in this day and age. But with the GZ34, the highest we can go is 60. Now the reason for this is because generally what happens is that with a rectifier tube, you have I think a flashback voltage or something. If you go too high in microfarads, if you go too high in capacity on your capacitor, your rectifier tube will arc, will spark, will overheat, will blow up, will die, will melt, all those things. So this is actually really vital. And if we put a 20 microfarad cap in, say we want to use a 5Y3 GT, then we can use a GZ34. But if we use a GZ34 and we put a 60 microfarad or 50 or 40, that's going to be twice the rating of what the 5Y3 can handle. So that's something to think about. What I might end up doing is I might end up doing something in between. We'll figure it out. But I think on the safe bet, we might use a 20 microfarad, and then that way we can use a 5Y3 or a GZ34. But we'll make sure that the first capacitor in the filter section is going to be rated at a high enough voltage for either of these rectifier tubes to pump out the correct voltage that they're going to need without blowing up or without exploding. You can already see how much work goes into figuring out what tube you're going to use. The next rectifier, or the next tubes that we're going to look at, or the tube that we're going to look at, is the 6 and 8. Now the one that came with this amp was a Mullard. This is no particular brand here, but basically they'll all be the same. And this is where we have to look at things like the current, not only of the heater, but of the tube itself as well. So let's see what we can find on the data sheet here. So the 6 and 8 is also known as the EBF80. I tried looking up a 6 and 8. I was not very successful. When I discovered that the equivalent or the European name, I believe, is the EBF80, I was able to find a lot more in data. So we can see here heater voltage 6.3 volts, heater current 0.3 amps, so 300 milliamp. Now this is where we have to start writing things down. I'm not going to right now, but we have to start thinking about 300 milliamp. Now do you remember what the heater current was rated at on our output, or on our power transformer? It was 3 amps. So this has already eaten up 10% of our power transformer. It has already eaten up 10% of its capacity doing that. Okay, anode voltage, which is basically our plates, maximum 300 volts. Anode voltage, screen voltage, also 300. Anode dissipation, 1.5 watts. Screen dissipation, 0.3 watts. Cathode current, 10 milliamp. That's important to know. And then this goes into sort of typical operational characteristics. So if we had something like, we're pumping 250 volts DC to the plates, we'd like to have a screen voltage of about 85 volts, control grid voltage -2, anode current would be about 5 milliamp, screen current 1.75 milliamp. Okay, mutual conductance, don't worry too much about this stuff. Anode impedance, don't worry too much about that. Now, amplification factor says 18. Now remember, if you know your 12AX7s, you'll know that the amplification factor on those is 100 mu. Now this is 18, so not a very high gain tube. We may stick with it, we may not. This talks about other amplifier stuff we don't need to worry about. And then this goes into a different valve. It's the EBC41. So essentially, heater current 300 milliamp, diode current 0.8 milliamps, so nearly 1 milliamp. We're doing all right there. Let's go to our next tube, the 6SN7. Now here, okay, 6.3 volt because it's a 6SN7. Its 0.6 ampere, so 600 milliamp. Let's forget about this tube for a moment. I'm going to go and look up, let's do this, 12AX7 data sheet. So this thing, this preamp tube, which is kind of like the 12AX7. Let's look at some of the data here. Let's scroll down. Let's see what we can find here. Okay, looking at the 6SN7, we're not finding much information on this data sheet, but we're finding enough to know what's going on. So we know it's a 6.3 volt heater. It's also telling us that it's a 0.6 ampere, 600 milliamp. So it's already using twice as much in current draw to the heaters than our 5Y3 GT. And if we look down here, this is some classic sort of typical operation. 250 volt at the plates, 0 or -8 volts on the grids. Amplification factor 20, again, not a high gain, valve. Okay, and plate current 9 milliamps. Okay, so if we again go down here to plate current, where are we? So diode current, that's 0.8 milliamp. Okay, and that's 9 milliamp. So it's using a lot more milliamps than that. Let's compare it to a 12AX7, a tube that we're more familiar with. 6.3 volt heater, again 300 milliamp for the heater current, not 600. So typical design values, 300 volt on the plate. Let's scroll down a bit more. Plate current 1.2 milliamp, amplification factor 100. So the 12AX7 is going to provide us with a lot more. These are just load lines and things like that. I'm not going to go into all that stuff. To be honest, I knew more about them years ago when I first started learning about tubes than I do now. But you get the idea. The 12AX7 is a pretty damn good preamp tube. We're on to the 6SL7. So we've looked at the 6SN7. We've looked at the 6N8. We've looked at the 5Y3 GT. Now we're on to the 6SL7. Now you can see here, okay, this is also a twin triode type tube. And it says it's a high MU twin triode designed for use in resistance coupled circuits as a voltage amplifier or phase inverter. And I believe in this particular circuit, that's what it was used for. We have a 6SL7 GT. The heater's a 6.3 volt. The heater current is 300 milliamps again. Have you figured out how many milliamps we're using? So here's 300. Here's another 300. That's 600 milliamps. This is 600 milliamps. So that's 1200 milliamps. And then we have 2 amps. That's a different circuit. So, okay, 1200 milliamps. That means on our high voltage line that we have 2 amps in total, we've got 800 milliamps left. So now we need to look at our 6v6 data sheet, because this is going to tell us what we've got left. Now remember, there's going to be 2 6v6s. So we're looking at the 6v6 GT up at the top right here. It says it's got a 6.3 volt heater, 0.45 milliamp, or sorry, 0.45 ampere, so nearly half an amp of current for the heaters. Okay, and then if we look down here, we'll start seeing some data. So let's say it's going to run a plate. That's single class A. Let's go down a bit more. So A, B, push-pull. This is what we're more than likely going to be using. Plate voltage is 285. I'm guessing we're going to be around that. We may go cathode bias, or we may go negative bias, like fixed bias. We'll see how we determine what we're going to do. Plate current, 70 milliamp. Power output, 10 to 14 watts, depending on how much voltage we're throwing at this thing. That gives you a little bit more information there of what we're using. So maximum signal plate current, it goes up to 92. So 92 milliamps, I should say. So just under 100 milliamps. So 100 milliamps times 2 is 200 milliamps. We're doing okay. We're up to about, what, 1400 milliamp? So we're still under the 2000 milliamps by about 600 milliamps. We're doing okay. So that tells me the 6v6 is the way to go. That's basically the complement of all the tubes. This is important when you're designing a valve amp of any nature. Now the next thing I'm going to do is look at different valve amplifier circuits and figure out one that I wish to copy or use. Like I said previously, I am thinking about the possibility of doing something like this Valco here. You know, it's got a field coil and all that stuff, but you can also do things like a Supro 1624T. So we got a 1624T. What have we got? Tube amps, schematics. So here we've got a Supro 1624T. This is the dual tone with tremolo. And we can have a look here at the schematic. We've got two 12AX7s, two 6973s. We'll have to look up the data sheet for that because we haven't looked that up. And then another 12AX7 down here for the tremolo circuit. So let's look at the 6973's data sheet. 6973 data sheet. All right, so we can have a look here and see that the power tube 6973's 6.3 volt circuit on the heaters, and then current at those heaters is 0.45 amps, so nearly half an amp. Let's look down here in typical operation. We might go down here to class AB. Plate voltage can be a max of 440, so they do offer a higher voltage. Plate dissipation 12 watts max, so they're about the same as a 6v6. Let's go here. Plate voltage 400, minus 25 for the bias. 50 milliamps, which is the maximum plate current. 107 with max signal. So we're always going to look at the zero signal plate current. Max signal plate current can vary. And it's supposed to give us a signal power output of 24 watts. Now that's what pretty much Supro currently tells you the amp puts out on their reissued 1624T. That's something to think about when you're cloning an amplifier, and you can see that we're still within spec in regards to our amount of current that we use in a circuit like this. We can go to a completely different amp. Let's go to this one here. I'm not familiar with this bottle. I'm just clicking on a random one. And of course it has to be rotated. So let's do that. If I can. Can I? Will it let me? Rotate clockwise. Here we go. So what's it telling us? 5881 6L6 GCs GB. Okay, well, that's fine, but the problem is with these amplifiers is that our power transformer will not be able to power a 6L6. So I think ultimately what we'll end up doing is going for something like a 5Y3 powered amplifier with the maybe some 12AX7s in the preamp section, and then a 6SL7 or a 6SN7, maybe a 6SL7 because it uses less heater current in the phase inverter section, and then followed by a pair of 6v6s, either cathode biased or perhaps even fixed bias to give us a little bit more higher output. So we'll see how that goes. And that's kind of what I'm thinking I'll probably end up doing. This turned out to be quite a long-winded video, but that's okay because that just goes to show you the amount of research that goes into building your own valve amp from scratch. And oftentimes I've had friends even say to me they'd love to buy one of those kits from overseas, more than likely, because no one in Australia makes kits. And they complain that they cost a fortune. They cost a fortune because someone sat there, like I just did, and done a lot of work to figure out what valves you need, how much you got to play with in regards to current capacity and voltages and all sorts of stuff. So I want to thank everyone for taking the time to watch this video. This is essentially part 2 of the amp building stage. So thanks again for watching, guys. I hope you appreciate it. Don't forget to click the button down below here and subscribe. I really appreciate the support that I get from everyone. So thanks again, and see you soon.